Test 3 is coming up soon, so I thought I'd give you this little review on earthquakes, and it'll really just be a start to a review on earthquakes, and then you'll continue the review on your own. So where we are is on our WebCT page. Went to the home page, then I clicked on the earthquake folder, and inside the earthquakes folder there's a link. It's actually the first link in the folder, study guide on earthquakes. So that's what we're looking at here. It's the material that was in the learning module, but it's in an outline form. And in some of the for some of the topics rather, I have a question like what is an earthquake, and then things you should know about earthquakes, like that the elastic rebound theory is how we explain what causes earthquakes, why they occur, and just if you don't remember what that's about, of course what you can do is you can go back to the learning module and look that up. Right, so here's the learning module, and it's on the second page. Talks about the elastic rebound theory, has a diagram that's from your textbook. The idea behind the elastic rebound theory is that when rocks are under stress, they undergo deformation. And when they're deforming, they're actually storing up energy. We could call the deformation strain, and we could say the rocks store up strain energy as they're under stress. When the stress gets to be too great, exceeds the strength of the rocks break, and the strain energy gets released, mostly as the shaking or the seismic waves that we feel shaking the earth during the earthquake. The rebound part of the elastic rebound theory is the idea that when the rocks break, they try to return to their original unstrained position. And sometimes that's not totally complete, but we can see that as the offset along the fault, that the rocks have tried to snap back to their original straight position across that fault. So let's go back to the study guide, and we can move on to the next topic. Where do earthquakes occur? We talked in the plate tectonics module about how earthquakes occur at all the different types of plate boundaries, divergent, convergent, transform boundaries. And that's expected because at the different plate boundaries we have rocks that are under stress due to the plates trying to move on either side of the boundary. And then we also talked in the learning module about how there are earthquakes that occur in places that are away from plate boundaries, far away from plate boundaries. They're called intraplate earthquakes, and a good example of that is the New Madrid seismic zone in North America. So once again, any of these topics you don't remember the material, you can go back and review that. Go to the next page here. Talks about where earthquakes occur. Map of the world showing how the epicenter locations for earthquakes that occurred over a 10-20 year period trace out the boundaries of the Earth's tectonic plates. And right then there's the discussion of intraplate earthquakes, focusing on this example of the New Madrid seismic zone. Right? So the way I'd encourage you to use the study guides is to go through them, and when it has some material on the study guide like know what these terms mean, epicenter and focus, ask yourself, do I know what they mean? And then go check on what you think the answer is by referring back to the learning module. See what the learning module says about it. Also try practicing for questions that don't have to do with definitions of terms. Questions like, what does the elastic rebound theory state about earthquakes? Well, there you want to try to practice explaining what the theory says, or explaining how things work. We're trying to get across not only terms, but also get you to have an understanding of how the earth works and how, what happens during earthquakes and why. So it's I think a very good idea to practice trying to explain how things work for the appropriate questions. Like for the different seismic waves, it says, know how each type of seismic wave affects the rock as they travel through the rock. Know their relative speeds. Know which travels through liquid, which doesn't. And, that's kind of basic factual information. The P waves, they're the fastest waves. They travel through Earth's interior, so they're body waves. When they travel through rock, they affect the rock by making the rock undergo successive compressions and expansions as the P waves pass through. And then the S waves are another type of body wave. It travels through Earth's interior. It's a little bit slower than the P waves. It affects the rock by making them undergo this shearing type of deformation as the S waves travel through the rock materials. Right? And the S waves are the ones that will not travel through liquids. They'll travel through solids only. The P waves travel through both solids and liquids. Right? So for understanding how to recognize them on a seismograph and understanding things like how to locate the epicenter of an earthquake and how the Richter magnitude of an earthquake can be estimated, we did the virtual earthquake exercise as a kind of an online lab, right? So you could go back to the virtual earthquake website and practice that again. Make sure you know how to determine the location of an earthquake's epicenter and the Richter magnitude of an earthquake. Okay, so I'll let you go through the rest of the material on your own here in this study guide. Right, go over all the different topics that were covered in the learning module, and for each of them, say what you think you know about it, but also go back to the learning module and check what the learning module has to say, right? And practice explaining how things work. Anything that you still don't understand after reading the learning module again, you want to ask me. You can send me email, you can ask during class or lab, and I'll try to explain. Okay, so study hard for the test. Good luck.